In this video, we explore the organised store of data in files and databases and the associated concepts. Useful programs will have a requirement to store and retrieve data from files. Files offer a permanent storage of data, unlike RAM, which is volatile. For some programs, a simple serial file will be sufficient, where the data is not stored in any particular order and with basic structure, one record after another. An example is a transaction file, for example a record of account numbers, withdrawals and the time of day at a cash point. Another example is an initialization file or an ini file. Here is a typical serial file with settings stored for a program. An alternative to the serial file is the sequential file. Here the data is stored in order of a key field and the order is maintained when new records are added. Sequential files are useful for storing master files. An adaptation of the sequential file is the index sequential file, where we maintain an index to allow groups of records to be accessed quickly. Here we see an example of data for a high score table in a computer game, where the order of the records is important. You'll notice that they're in order of score. Before database technology became the norm, large sequential files would have been kept on magnetic tape or disk. An index was often used to make it quicker to find records, much like the index of a book to find a particular page. These were index sequential files. Databases are structured, persistent collections of data. When handling large datasets, a database makes processing much more efficient, and it reduces storage requirements by avoiding redundancy. It allows different users to only see relevant data. The database is the structured data itself and is managed by an additional layer of software called the Database Management System, or DBMS. The DBMS provides a manipulation language to access and change the data, integrity to ensure the efficiency and structure is not compromised, additional security, and an interface for other programs to access and use the data without concern for the underlying structure. The data and program are said to become independent. You can change the data without affecting the program, and you can change the program without affecting the data. Microsoft Access is an example of a very simple DBMS for small-scale projects, and we'll see examples of that in a moment. Other industry standard DBMSs include Oracle and SQL Server that allow for millions of records and users simultaneously. A database is typically constructed of tables, which are also called entities or files, that hold the data in rows, called records or tuples, and columns, also called fields or attributes. You'll find that a lot of these words are used interchangeably in databases. Also queries, which allow for the manipulation of data, searching, sorting, filtering, adding, modifying and deleting, as well as providing provision for forms or a user interface to be built and reports of the data to be output. Here we see an example of what is known as a flat file or single table database. There is just one table and all the data is stored within it. This is a very inefficient way of storing data because it is not easy to query. Notice how each subject a student studies appears in more than one column. It is much harder to query a database, for example to find all the students studying English in this way. Also notice that much of the data is duplicated. This is not only inefficient use of storage, it also means that errors can occur between different records very easily and the integrity is compromised. In order to address these issues, we must use a relational database. A relational database has more than one related table. The correct structure for this database is shown here. We now have 3 tables, one for the student, one for the subject studied, and one for the tutor group information. You will notice that data is no longer duplicated and the subject studied appears in just one column, making querying much easier. The process to get from a flat file to a fully relational design is known as normalization and will be covered in another video. The tables can be shown in an abstracted view like this. Notice the relationship between the tables. This is known as a one-to-many. one record in the tutor group table is related to many records in the student table, which is related to many records in the subject studied table. This means one tutor group can have many students and one student can study many subjects. Designing the tables and illustrating them in this abstracted view is known as entity relationship modelling. Note that Microsoft Access uses the infinity symbol to signify a many relationship, but that's not the official symbol. You'll notice on the diagram above we're using what's known as a crow's foot, which is the official symbol to use to signify a many side of a one-to-many relationship. With a relational database, there are a few key points to notice, excuse the pun. Firstly, each record must be unique. A special field known as a primary key is the unique identifier for the record. Here in Access it's signified with the key symbol, so the tutor group identifies one unique record for each tutor group, and the student reference number identifies a single student. For example, you may have two students called John Smith, even in the same tutor group, but they cannot have the same student reference number. The student reference number makes that student unique. A foreign key is the field on the many side of a relationship that links to the primary key on the one side of a relationship. So for example, the student reference number in the subject studied table links back to the primary key, student ref, in the students table. Therefore, the student ref in the subject studied table is known as a foreign key. The tutor group in the students table links back to the tutor group in the tutor groups table. So the tutor group in the students table is a foreign key. There are three types of relationship. Relationships may be one-to-one, although the fields could be in one table in this situation, and relationships can also be one-to-many. Theoretically, relationships can be many-to-many, but this would always be broken down into two one-to-many relationships. You cannot design a database with many-to-many relationships, but they're often shown when entity relationship modelling just for completeness. Consider this example of cars and parts. A car has many parts, and a part may fit many cars. This would be resolved by introducing another table with two foreign keys. So we have a car table and a part table, and in between them a car parts table. So the many-to-many relationship is broken down into two one-to-many relationship. One car can have many parts, and one part can fit many cars. The primary key is also what is known as an index. The database management system uses this field to quickly find records. Data is stored physically in the order in which it is entered, but we may want to query and output it in a different order. Rather than actually moving the records around, which would be hugely inefficient, a series of additional indexes are stored. Any field that is indexed so that it can be sorted quickly is known to have a secondary key. So in this example, although the primary key is the tutor group, uniquely identifying one record from any other, a secondary key might be the tutor, so that we can quickly sort the tutors in order.